Today we're going to be going through the 2018 Unit 1 paper for pure mathematics. Alright, so let's get into it straight away. It says, let P and Q be two propositions. Complete the truth table. So, very easy question. C sec IT, not P, is just going to be false, false, true, true. That's not P. Alright, not Q. We see Q, we have true, false, true, false. So this is going to be false, true, false, true. Alright, no issues so far. Alright, P or Q, it's only going to be true when either is true. So true or true is true. True or false is true. False or true is false. And false or false is false. So that's what we get. Now, not of P or Q is a negation of this. So it's going to be false, 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 true. Finally, they want what is not P and not Q. So false and false is false. False and false is false. False and true is false. True and false is false. And true is true. So that would be the truth table for this. Nice. Now it says, hence state whether these two are logically equivalent. So you can say, yes, according to the results from the truth table, according to the results from the truth table, you can tell them that the negation of P or Q, you can tell them that it is logically equivalent to the negation of P and it's logically equivalent to the negation of P and the negation of Q. So we're just telling them that, of course, these two statements are logically equivalent. Nice. Oh, I left out that and right here. So they are logically equivalent since they have the same truth results here. Nice. Second part of the question says, a binary operation defined by circle plus is defined on the set of real numbers such that a circle plus b is equal to 2a plus 3b. Find 5 circle plus 2. So 5 circle plus 2 means we're going to replace a with 5 and we're going to replace b with 2. So 5 circle plus 2 is equal to 2 times 5 plus 3 times 2. That is 10 plus 3 times 2 is 6. That is equal to 16. So 5 circle plus 2 is equal to 16. Nice and easy, soft. That takes care of question 1. Question 2 says, prove that circle plus is closed in R. So first we can tell them A is a real number, B is also a real number, right? And so that means that what was it again? 3a plus 2b is also going to be a real number because the sum of two real number is closed under addition. So this is also a real number. But 3a plus 2b, that's just a star. This is just a star b. And so this implies that a star b is closed in R. Since a star b is equal to this, a star b is closed in R. Nice and easy. So it says this determine whether, oh, why am I saying star? It was circle plus. I'm changing the operator. My apologies, circle plus. Circle plus. All right. Now that we got that out the way, let's continue. Determine whether circle plus is commutative. So as we showed around here, we got 5 circle plus 2 is 16. So the easy way would to just be check if 2 circle plus is the same. So let's write it down. We got that 5 circle plus 2 is equal to 16. So let's check to see if 2 circle plus 5 is 16. So 2 circle plus 5 is going to be equal to 2 circle plus 5 is going to be 2 times a, so it's going to be 2 times 2 plus 3 times. Oh, it was 2a plus 3b, so that means up here it should have been 2a plus 3b. I wrote 3a plus 2b. This is 2a plus 3b, but it's still going to be a real number anyways. 2a plus 3b. So down here, 2 circle plus 5 is going to be equal to 2 times 2. 2 times 2 is 4 plus 3 times b. In this case, b is 5. 3 times 5 is 15. So 4 plus 15 is 19. And so circle plus is not commutative. Circle plus is not commutative. These two are not the same. They're not the same, so they're not commutative. All right. So the operator is not commutative. Nice and easy. So nice and easy. So we showed it's not commutative. Nice. Just check in 10, 16. Yes, that's fine. 2, 2 is 4, 15, 19. Good. All right, part C. Part C says given that 2x plus a times x minus 1 plus b times x plus 1 is equal to cx cubed minus 10x squared minus 2x minus 10. It says to determine the values of a, b, and c. There are two ways we can do this. We can set up an equation for a, b, and c using sums and products of roots. We could, because they have 3 equations here. Yeah, we could generate 4 equations and solve for a, b, and c. Or you could expand this left-hand side. So method 1 would be to expand this side. All right. So I'm going to do it method 2 first. Or method 1. Let's go method 1 first. I'm just itching to do it both ways. So let's look at method 1. Method 1 is the way where you expand this left-hand side. So 2x plus a times x minus 1 will give you 2x squared. 2x times minus 1 is minus 2x plus ax. So it's really plus. Instead of writing minus 2x and plus ax, just put plus a minus 2 bracket times x minus a. If you're wondering where this comes from, 2 times this is 2x squared, this times this is minus 2x, and this time this is ax. All I did was factor out the x. So that's that. Then you're going to multiply this by bx plus 1. Multiplying this by bx plus 1, it's going to be 2x squared times bx. That's 2bx cubed. And this time this is plus 2x squared. And this time this is going to be plus b times a is ba minus 2b. This is now ba minus 2b times x squared. Then we have 1 times this is just going to be plus a minus 2 times x. Then you're going to have minus abx minus abx minus a minus abx minus a, and all of this is equal to your cx squared plus 10x cx cubed plus 10x squared minus blah blah blah. So let me put it in a different color. Don't want to get it confused. So in the red is your left hand side, then over here is your right hand side, which is cx cubed plus 10x squared minus your 2x minus 10. Now what you do then is you equate your x cubed term. So you equate your 2b, and 2b is going to equal to c. So equating x cubed terms, we're getting that 2b is equal to c. That's one equation. Then equating your x squared terms, as you can see, we have this as an x squared term and this as an x squared term. So what we're getting is your x squared term is really 2 plus ba minus 2b. And that's equal to 10. That's what you're getting. That part is equal to 10. And so if you bring over the 2, you're getting ab minus 2b is equal to 8. That's what you're getting equating your x squared terms. Equating your x terms, what you're getting is a minus 2 times x minus abx is equal to minus 2. So equating your x terms, you're getting a minus 2 minus ab, and that is equal to negative 2. That's equal to negative 2. So if you want, you can bring over the minus 2 and add 2 to both sides. So really you're getting that a minus ab is equal to 0. That's what you're getting. All right. So these are the equations that we're finally reducing them down to. And then finally equating constants, we have minus a. Yeah, we have minus a is minus 10. And so from that, we're getting a equal 10. Now these questions get very easy once you find a. If A is 10, you plug 10 in here. And so that means 10 minus 10b. If A equals 10, that implies 10 minus 10b equals 0. And if 10 minus 10b equals 0, then therefore b equals 1. B is equal to 1. If b is equal to 1, we can check it here. 10 times 1 is 10. 10 minus 2 is 8, so good. Then we get C, because C is 2b. And so therefore C is equal to 2 times b, and so C is equal to 2. So in conclusion, we get A equal 10, B equal 1, A equal 10, B equal 1, and C equal 2. Log 4 of 2x minus log to base 2 of x plus 1 is equal to 1. The first thing we have to identify is that the bases are not the same. So let's convert the two of them to the same base. So I'm going to convert log to base 4 of 2x plus 1 to base 2. Just convert both of them to base 2. Log to base 4 of 2x plus 2 is going to equal to log of the new base. So it's going to be log to base 4, log to base 2 now of 2x plus 2 over log to base 2 of 4. Log to base 2 of 4. But log to base 2 of the number, yeah man, so this works out to just be 2. So in the denominator, it's just 2. So now this, using this, we're going to solve this question now. So this becomes now log to base 2 of 2x plus 1, 2x plus 2, so it's log to base 2 of 2x plus 2 divided by 2. Alright, instead of saying divided by 2, better we put it like a half on the outside. So we can put a half on the outside here. Plus, or minus rather, log to base 2 of x plus 1. And this is equal to 1. Now we can then combine it as one logarithm. So I can bring up the half. Up here. Bringing up the half, it becomes square root. So writing it as one log, it's going to be log to base 2 of the square root of 2x plus 2. And that is being divided by x plus 1. And this is equal to 1. If this is equal to 1, what can we do? Well, the log of a base of a number is equal to a power such that the number, so this implies that the square root of 2x plus 2, square root of 2x plus 2 over x plus 1 is equal to the base to the power. So this is equal to 2. So we cross multiply now. We're getting that the square root of 2x plus 2, square root of 2x plus 2 is equal to, cross multiply, we get 2x plus 2. Wow. So the square root of 2x plus 2 is equal to 2x plus 2. Now, if you want, some persons might want to look at it like, if you wanted to call this A, let A be equal to the square root of 2x plus 2. Or maybe I want to call a 2x plus 2. So if a is equal to the square root of 2x plus 2, then you're solving a is equal to a squared. And carrying this over, then really and truly you're solving a squared minus a is equal to 0. And if a squared minus a is equal to 0, you factor out a, and you're getting a equals 0, or a minus 1 is equal to 0. But then what was a? A was the square root of 2x plus 2. So that implies that it's either the square root of 2x plus 2 is equal to 0. And if the square root of 2x plus 2 is equal to 0, then you square both sides. And from that, you're getting that 2x plus 2 is equal to 0. And so x is equal to negative 1. So you're getting x is equal to negative 1. Or if a minus 1 is equal to 0, then the other possibility is you're finding now the square root of 2x plus 2 is equal to 1. So when you square both sides, you're getting that 2x plus 2 is equal to 1. And if 2x plus 2 equal 1, then x must be equal to carry over 2 divided by 2, x equal minus a half. X is equal to minus a half. Now if x is equal to minus a half, let's check it. X can't equal negative 1. Let's just say that right away. If x is negative 1, you get in a log of 0, and the log of 0 does not exist. So this one is not valid because we cannot work out the log of 0. So this one is not valid. So the final answer is just x equal minus a half. So the final answer is x is equal to negative 1 over 2. That's the final answer. And that completes question number 1. Nice. Moving right along. Question 2. Question 2 says the diagram below shows the graph of the function f of x. In this case, it says sketch the inverse of f of x. Sketch the inverse of this function. So let's do that. Sketch the inverse of this function. I like to do this first. I like to draw the line y equal x before I sketch the inverse. So I have the point 10, 10, pass through the origin. So this is just the line y equal x I'm putting in. That's just the line y equal x. And you might wonder, why do I need to do that? When I'm sketching inverse, I like to just put in the line y equal x. Next thing is that, look at this, 0, 0 is on this curve, so 0, 0 will on the inverse as well. There's a point 2, 4, 6, 8, 10, so this is 2. When x is 2, y is 5. So when you interchange them for the inverse, we need to plot the point 5, 2. So you have 2, 5, then the inverse will have 5, 2. So this is 2, 4. This will be 5. Wait, that's not 5. My apologies. Why am I giving such poor calculations? This is 2, 4, 6, 8. This is 8. This is 8. So 2, 8. And so if 2, 8 is right here, then the point on the curve is 8, 2 on the inverse. So this is 4, 6, 8. And this is 2. All right. So the curve is going to go like this. The inverse curve is going something like this on that side. Now let me see how it behaves down here. Now I have a point minus 2, 8, minus 2, 8, and so I need to go minus 8. I have a point minus 2, minus 8, so I need to go minus 8, minus 2, which is here. That's a point. And so that this inverse going like this. Pass through that point. Alright, and so this will be the inverse as f inverse of x. Nice and easy, very easy question, soft. All you had to do was just reflect this in the line y equal x. Just reflect the graph in the line y equal to x. Now it says use a graphical method to show f is bijective. So using a graphical method, the first thing to be bijective is 1 to 1. So we're going to do the horizontal line test to show that it is 1 to 1 first. So doing the horizontal line test, so right here, you can see using horizontal line test, f is 1 to 1. Clearly, using the horizontal line test, we can see that f is 1 to 1 right here. We do the horizontal line. This red line is the horizontal line test. Nice. So we do the horizontal line test. So f is 1 to 1. Now we need to show that it is surjective. Now, using the same horizontal line test, as you can see, stopping even down here, for all x, for all y, there is a corresponding x. And for all x, there is a corresponding y. All right, so using horizontal line test again, using line test, you can see that the codomain is equal to the range as all y values are mapped to. All right, and so the codomain is equal to the range. So using that method, we can say hence, since f is 1 to 1 and onto, hence f is bijective. Nice and easy, soft, a capital T. Now that we showed f is 1 to 1, we go to part B. Part B says prove that x minus y, the modulus of that, is less than or equal to the modulus of x minus z plus the modulus of x minus, modulus of z minus y. Now before we do this question, just want to write down what the triangular inequality is. Going back to the triangular inequality, all right, well, let's do it this way then. All right, so the modulus of x minus y, modulus of x minus y, well, the modulus of x minus y is equal to the modulus of, we can write this as x minus y minus z plus z. Yeah, man, though we can do that. Definitely we can do that. We definitely can do that. Then this right here, we can break it up as, we can break up this now as, we're going to group the x with the minus z, x minus z. We're going to group that part together, plus we're going to group this part together now. All right. Then we're going to group this part together now. We're going to group this part together, which is now y or z minus y. Group those parts together. Nice. So we have that the modulus of this is equal to the modulus of this, which is good, which is good, which is good. Remember, modulus means length. Modulus means length. All right. And so what we have then in this case, we have that x minus y, the modulus of x minus y is equal to the modulus of this. So that implies, what does modulus mean? That implies that the modulus of x minus y, modulus of x minus y is equal to this square plus this square square rooted. That's equal to x minus z square. That's what modulus means, length, x minus z square plus z minus y square. All right, let me write this a little better. Z minus y bracket square, and all of this is being square rooted. That's what modulus means. So this is what we have. All right, so this is now the modulus of x minus y. Now look at this now. Now this now, the modulus of x minus z would just be x squared plus z squared square rooted. And this part, let's just work it out. We're gonna see. So the modulus of x minus y is working out to be the square root of, inside this bracket would be x squared. This would be x squared minus 2xz. And this would be plus z squared. This would be plus another z squared minus 2yz plus y squared. All right, so that is the modulus of x minus y. The modulus of x minus y. We're almost finished, don't worry. Modulus of x minus y is just working out to be the square root of x squared plus y squared, x squared plus y squared plus 2z squared minus 2x minus 2xz minus 2yz. That's the modulus of x minus y. And clearly, this is going to be less than, look at this now. Now, the modulus of x minus z, that's going to be equal to x squared plus z squared square rooted. This is x squared plus z squared square rooted, and the modulus of z minus y, modulus of z minus y is equal to the square root of z squared plus y squared. All right, clearly. All right, so what we're saying is clearly the sum of these two must be greater than this. It has to be, it has to be. Why does it has to be? This has some subtracting in. All right, this has some subtracting. This has to be. This is going to be greater than this. So what am I saying? I'm saying that the square root of x squared plus z squared plus x squared plus z squared plus the square root of z squared plus y squared, all of this is greater than or equal to the square root of, I can't write out all of that, so I'm just going to show that this is greater than the modulus of x minus y, where the modulus of x minus y was this. And so the modulus of this part was x minus z. So the modulus of x minus z plus the modulus of x, modulus of x minus z plus the modulus of z minus y. This is definitely greater than or equal to the modulus of x minus y. So that's the proof for it. Nice and easy, soft. Now what you could do is, you could even test it like right here. Let's say x, y, and z was 1. If x, y, and z was 1, right, just to test it, look at this. If x, y, and z is equal to 1. Let's say all of them is 1. If x is equal to y, which is equal to z is equal to 1. Look at this. If all of them equal 1, in this case, you would get the modulus of x minus y to be 1 square plus 1, 1 plus 1 plus 2 times 1 is 4, minus 2, that's 0. In this case, it would be 0. In this case, you'd be getting that the mod of x minus y. In that case, you'd be getting that that's equal to 0. Now look at this now. X has 1, and x has 1, you get in 1 plus 1 is 2. So you get in that, in this case, you'd be getting the square root of 4. In this case, you're getting it to work out to be 4. So that if x, y, and z is 1, down here, so you'd be getting the mod of x minus z plus the mod of z minus y. Using the formula, you'd be getting it to equal to the square root of 2 plus the square root of 2. You'd be getting square root 2 plus square root 2, which is 2 root 2. So clearly, as you can see, this is true. This was just an example. You wouldn't put an example in the proof. It's just to show you from calculation. Because this has the subtract right here, then definitely these two just being adding is always going to be bigger than this. Once some subtracting is taking place, then in here under the square root is just pure plus. Clearly, this is going to be bigger than this. That's how you prove that. So you shouldn't have to be putting in it if that. That's the proof. Moving right along. Solve this inequality. So let's go ahead and solve this inequality. Solving this inequality. So what we do first is, moving right along, we're going to solve that inequality. So we have the mod of 6x plus 6x minus 2 plus x squared is less than or equal to 5. So first thing we need to do is subtract x squared from both sides. We get that 6x minus 2, the mod of it is going to be less than or equal to 5 minus x squared. And if that is true, then that means that 6x minus 2 is going to be between 5 minus x squared, and it is also between minus of 5 minus x squared, which is x squared minus 5. Now to solve this inequality, first thing I'm going to do is I'm going to consider this part first. So I'm going to consider the left-hand side of the inequality first. All right, so I'm going to consider the left-hand side first. Looking at the left-hand side of the inequality, I am solving 6x minus 2 is greater than or equal to x squared minus 5. So looking at that, I'm getting, bring over this and bring over this, I'm getting 0 is greater than or equal to x squared minus 6x. Adding 2 to both sides, I get minus 3. Can I factorize this? Let me see. 6 squared minus 4 times 1 times minus 3. Alright, so I can't factorize this, so I'll go to the quadratic formula. That's crazy. So I go to the quadratic formula to find what x would be. Going to the quadratic formula, x would be equal to minus b, which is 6, plus or minus b squared minus 4ac over 2a, which is the square root of 48 over 2. So I'm getting x would be the square root of 48. I think that is 48 can be broken up as 16 root 3, 60 root 16 times root 3, and the root of 16, I believe the root of 16 is 4. And then 4 over 2 is 2. So I would write this as 3 plus or minus 6. 4 over 2 is 2. So it's 3 plus or minus 2 root 2. So from this end, the solution for this would be that x is between 3 plus root 2 and x is between, from right here now, x is between 3 minus 2 root 2. I left off the 2 right here, 3 plus 2 root 2. So that's from the left-hand side of the solution. Going to the right-hand side now. Going to the right-hand side. Going to the right-hand side, I would be having that 6x minus 2 is less than or equal to x squared minus, the right-hand side was 5 minus x squared. So I have that x squared. This would be 5 minus x squared. Bringing it over, I have x squared. Was it 5 minus x squared? Let's go again, the right-hand side. 5 minus x here, 6x minus 2. So this would be 6x minus 2 is less than 5 minus x squared. Bringing over this, I would get x squared plus 6x minus 7 is less than or equal to 0. So what I would be getting is, if I were to factorize this, this one can factorize. It would be x, 7, and 1. Signs are different. The greater product positive, so this is plus, and this is minus. This is less than or equal to 0. And so to finish it off now, in this case, from this, so from the right-hand side, let me separate the solutions. So from the right-hand side, what I'm getting is x is between, this looks like 1 and minus 7. X is between 1 and minus 7. All right, so now what will be the final solution? So I'll put the final solution in black. The final solution will have to incorporate both of them. Final solution. Let's look at this. 3 minus 2 root 2. That's 0 point something, and 3 plus 2 root 2 is 5.83. So what will be the final solution? The final solution will be from the lower value, which will be from minus 7 less than or equal to x and x will be less than or equal to 3 plus 2 root 2. So this is the answer. When you combine these two inequality, this is what you would get. I want to write it so it's a little more clear. X is between 3 plus 2 root 2 and it is greater than or equal to right here, which is minus 7. That's the final answer. Anytime you get an answer, you want to check it. So you check it by putting a number. This don't look like minus 7, look like 7. It should be minus 7. So this is the final answer. That's the answer. X is between 3 plus 2 root 2 and minus 7. When you get your answer, you want to check it. So you can put in a number like negative 6. Check it. 6 times negative 6 minus 2, that's 38 is the modulus. Then 5 minus negative 6 squared. So you can check it like over here. Let's see. Negative 6. Plug in negative 6. Negative 6. Plug in negative 6. And this up here, you get 6 times negative 6 minus 2. That's 38 plus negative 6 squared. Well, negative 6 won't be right. Let's check it from negative 4. 6 times negative 4 minus 2 plus negative 4 squared. That's negative 6 times negative 4 square. 6 times negative 4 minus 2 is 26, and 26 plus negative 4 squared is 42. That's not giving me less than 5. So the minus 6 is not correct. Let's check this solution. All right, this is the good thing about modulus question. You have to check your solution. So as you can see, the minus 7 part is not working. So let's check from 3 minus 2 root 2. That is 0 point something. So let's check from 0. 0 minus 2 plus 0, that's good. And so indeed, the smaller part works. So 3 minus 2 root 2 works. So in this case, that's why it's good to check your answer. So what we're getting when we check, this is the final now when we check it. We're getting that x is greater than or equal to this part, 3 minus 2 root 2. When we check it, 3 minus 2 root 2. All right. And it's less than or equal to, let's check if 1 is good. When you put in x as 1, 6 times 1 minus 2 plus 1, yes. So 1 is fine. But it can extend up to 3 plus 2 root 2. So let's check if 3 plus 2 root 2 works. Let's check when x is 2. 6 times 2 minus 2 plus 2 squared. That don't work, so it's top of 1. So this is what happened. This is the final answer when you combine these two inequalities. So this one combined with this one gave the final answer to be that. So that's the final answer. We combine the two inequalities to get that. Nice and easy. 8 well-deserved marks. All right. Next part of the question, it says, given alpha, okay. Given that alpha and beta and gamma are the roots of the equation. It's too much. Go a little bit, yeah, that's better. Given alpha, beta, and gamma are the roots of this cubic equation, determine the equation whose roots are 1 over alpha square, 1 over beta square, 1 over gamma square. So first they give us a cubic, and these have roots alpha, beta, gamma. So the sum, which is alpha plus beta plus gamma, that is equal to minus b over a. It's going to be equal to minus alpha plus beta plus gamma is minus 1 over 2. So the sum is 1 over 2. Then the product by 2, which is alpha times beta plus beta times plus beta times gamma. Alpha times beta plus beta times gamma plus alpha times gamma. The product by 2 is going to be equal to c over a, which is 0, because there's no x term. Then alpha, beta, gamma. Alpha, beta, gamma is equal to minus d over a. So it's going to be equal to minus 1 over 2. So it's minus d is minus 1 over a. All right, so now we have the sum. We have this, and we have the pairwise product. Now to find a new cubic equation, we need the sum of the new cubic. The sum of the new cubic, the sum is going to be equal to 1 over alpha square plus 1 over beta square plus 1 over gamma square. To work this out, we're going to have to find their LCM, and the LCM of this is going to be, common denominator is going to be alpha, beta, gamma, all square. And when you work this out, you're going to get this into this leaves alpha, this into this leaves beta gamma square. So this will leave beta gamma all square plus this into this will leave alpha gamma all square, and this into this will leave alpha beta all square. That will leave alpha beta all square. So what that works out to be now is, this works out to be equal to alpha beta. This is the formula that they give us for this now. Here's the formula. They tell us that it's equal to alpha beta, beta gamma plus gamma alpha all square. So it works out to be 0 square minus 2 alpha beta. Alpha beta is minus a half times minus 2. That works out to be plus 1 times alpha plus beta plus gamma. Alpha plus beta plus gamma is a half, so it works out to be 1 times a half. Now if this is divided by alpha beta gamma square. Alpha times beta times gamma is, alpha times beta times gamma is minus a half. So it's minus a half square, which is a quarter. You just need to work out what's a half divided by a quarter. Half divided by a quarter, and that is 2. Half divided by a quarter is 2. So that's the sum of the new cubic equation. Now let's find the product, E2. So the pairwise product now is going to be 1 over alpha times beta square, 1 over alpha times beta square, plus 1 over 1 over alpha times gamma square plus 1 over beta gamma square, beta gamma square. Nice. So again, we're going to use the LCM. And the LCM for this is going to be alpha, beta, gamma, all square. And what we're going to get when we work this out is this into this is now, it just leaves gamma square. This into this leaves plus beta square. And this into this leaves alpha square. So gamma square plus beta square plus alpha square. But what's gamma square plus beta square plus alpha square? Let's check it out. They give us a formula that gamma plus beta plus alpha square is alpha plus beta all square, and alpha plus beta plus gamma is a half, so it needs to be a half square. So it's going to be a half square. So it's a half square minus so it's a half square minus 2 times alpha gamma beta gamma. Alright, minus 2 times 0. So it's minus 2 times 0 over alpha beta gamma all square. Alpha beta gamma all square. Alpha beta gamma is minus a half. And so we have minus a half all square. Minus a half all square is a quarter. So we have a half square divided by a quarter. That will give us the product by 2. A half square divided by a quarter is 1. Nice. So now P3 is now going to be the product by 3, and the product by 3 is just going to be 1 over alpha beta gamma all square. And 1 over alpha beta gamma all square is just equal to 1 over alpha beta gamma is minus a half square, and 1 over minus a half square, I think that's 4, but I'll just check it out just to make sure. 1 divided by a half square, yes, it's 4. And so the new equation, so the new cubic equation, let's write it here. So the new CE, new cubic equation, will be given by x cubed minus the sum of the roots. The sum of the roots is 2, so it's x cubed minus 2x squared plus the product of the roots. Product of the roots is 1, so it is plus x minus the product by 3 of the roots, which is minus 4, and that's equal to 0. That's the new cubic equation. Nice and easy, soft. This takes care of module 1, module 2 time, onto module 3. Nice and easy. Number 4 is 2. Bear that in mind. So I'm just going